Hello everyone, welcome back to the 5-Minute Tech channel. Today we'll continue on our journey and learning more about microservices. In this part, we'll be talking about resiliency in microservices and the patterns associated with it. This is the fifth part of the series of learning of the Polyglot microservice architecture, where we are developing an entire application full stack. So this is the full application layers that we are developing, and in this part we'll be talking about building resiliency into all these services. So what is resilient microservice? Resilient microservices are designed to handle failures gracefully and maintain their functionality even in the face of any disruptions. They employ various patterns and techniques to ensure that the system remains stable and responsive, and despite any issues that may arise. Microservices needs to be resilient to failures and must accept partial failures. There will be scenarios where your microservices may go unresponsive or is not able to process the request. So we have to design microservices to be resilient for these partial failures, and they should have the ability to recover from the failures and continue to function. In a resilient microservice architecture, each service is built to be fault tolerant and can recover from errors without impacting the overall system. This is achieved through implementation of different patterns, which we'll be talking about, which include circuit breaker, retry pattern, timeout pattern, bulkhead, and fallback. And along with that, there is a cache aside pattern. So these are the patterns which we'll be talking about. First one is circuit breaker. That is, it prevents a service from repeatedly attempting an operation that is likely to fail by opening a circuit there after a threshold of failure. This stops further attempts until the service recovers. And the use case of the circuit breaker pattern will be like to protect the service from cascading failures and reduce the load on the failing components. The retry pattern is automatically retries a failed operation a specified number of times. We can configure that before giving up. And it handles transient faults that may resolve themselves after a short period of time, like a network issue and all these things. Timeout pattern is something like we set aside a maximum time limit for an operation to complete. If the operation exceeds this time, then it is terminated. And it prevents resources exhaustion and improves responsiveness by not waiting indefinitely for a response. Now, bulkhead pattern is something which isolates different parts of a system to prevent a failure in one part from cascading to other parts. This involves partitioning the services into different areas or different resources, and it ensures that the failure in one service or resource pool do not affect the entire system. That is the bulkhead pattern. And the fallback pattern provides an alternative of response or action when a service fails. This can include returning cache data or a default data. Ensures the system can continue to function even if a particular service is unavailable, and prevents customer dissatisfaction. Cache side pattern caches the data, reduces the load on a service, and improves the performance. The application is responsible for loading data into the cache as needed, and that can be orchestrated. It improves the performance and reduces the impact of service failures. So moving on to the circuit breaker pattern in detail, a circuit breaker pattern monitors the communication between the services and follows the errors that occur in a communication. Okay, and an example of this error is like an HTTP API and that has been requested returns a 500 error. So what we do is when the error happens, in this case the system exceeds certain threshold value, the circuit breaker turns on and cut off the communication to that service and returns a previously determined error message. While the circuit breaker is open, it continues to monitor the communication traffic, and if requested, the service starts to return successful result, it becomes closed. So this is the representation of the full flow, the closed, open, and the half open. Circuit breaker pattern remains closed in this mode. In the closed mode, the circuit breaker pattern. The circuit breaker pattern has three modes. The closed mode, the circuit breaker is not open. All requests are executed as normal. The circuit breaker prevents the application from repeatedly trying to execute an operation while an error occurs in the open mode. In the half open, the circuit breaker executes a few operations to identify whether the service is up or not, and if error occurs, the circuit breaker will be opened. If not, it will remain closed. So this is the representation from the Microsoft side, wherein we are representing how the resiliency is built into a service wherein the call is happening from API gateway. Here the representation is through Poly, but we will be developing an application or the system without any library. We will be building in all these code wherein we will be demonstrating the circuit breaker pattern. Retry pattern, it's an inter-service communication that can be performed by HTTP or gRPC, etc., any protocol, and can be managed. But when it comes to network, service, server, and such, physical interruption may be unavoidable in certain scenarios. If one of the services returns HTTP 500 and is not working, the transaction may be interrupted and an error may be returned to the user. But when the user restarts the same transaction, it may work. That happens in certain cases where the network goes down and it comes back up and there is a fluctuation in the network. In such a case, it would be more logical to repeat the request made to the 500 returning services so that the user will be able to perform the transaction successfully, even if it is a little late or post the time in which the transaction happened. And here is the representation on how it happens. First, there is an initial delivery attempt, and then there is a 2-3 retries which is done until the final success happens. Now, it is similar. It works closely with the circuit breaker pattern, and in the adjacent the image, it is a presentation as we just talked about, wherein it is configured to allow up to 4 retries. You are seeing that, and after the retry phase, then it is returned error. Otherwise, it is returned 200 if it is successful. Now, bulkhead design pattern aims to isolate the occurring error which is in one location, does not affect the other services. So this is like a bulkhead design in the ships, wherein the watertight bulkheads are staged and put into the container. The errors which in one location does not affect the other services by isolating the services. The main purpose is to isolate error place and secure the rest of the services. Now, this inspiration, as I talked about, comes from the ships. While ships or submarines are being built, they are made not as a whole, but by shielding them from certain areas. So if there is anything happens, a flood or fire, the relevant compartment is closed and isolated, and ships and submarines can continue its mission. Microservices must be able to respond to user requests by isolating the relevant services, so the error that will occur in the service does not affect all other services. That's the whole goal of our pattern here. Now, bulkhead pattern example: app without bulkhead and app with bulkhead. App without bulkhead, if you see, if everything request goes through and every service exposed to the similar kind of a request, whereas in bulkhead it is services are isolated, and that can be handled if any one of the service goes down through load balancing or any other principles which we can apply to the bulkhead pattern. Now, timeout pattern in microservices sets a maximum time limit for an operation to complete. If the operation takes longer than the specified time, it is terminated. Now, this helps to prevent resource exhaustion, improves system responsiveness. Now, when a system is not responding within a time period, then we come out of that service call and then terminate that. Now, we define the timeout duration, then apply the timeout to the operation which we want, and then we handle the timeout execution exceptions which happens around it. This prevents resource exhaustion, as we talked about, and improves the responsiveness, and the resiliency is increased. Now, next is fallback pattern. Fallback pattern is a resilience design wherein what we use to provide an alternative or backup solution when the primary service or component fails. It helps ensure that the application continues to function and provide some level of service even if certain parts are not working as expected. So you can see here in the diagram or the image wherein a client is trying to access a particular API hosted on server 1, and it could be routed to server 2 if server 1 is not available. Now, there are different ways we can implement it. We define a fallback, implement a fallback logic on which it will work, and handle the fallback failures gracefully. Again, this ensures connectivity and enhances user experience. Now, cache aside pattern, also known as lazy loading in common terms, is a caching technique used to improve the performance and efficiency of your microservice. In this pattern, the application code is responsible for loading the data in the cache as needed, and if the data in the cache is not latest, or it needs to be retrieved from an underlying data source and then added to the cache for future requests. How cache aside pattern works basically is it checks the cache and tries to retrieve from the data source, updates the cache and returns the data. Now the benefit of your cache aside pattern is, again, it improves the performance because you have cached the specific response from the request which is coming through, and then it helps in scalability and flexibility of your service. So that was pretty much the detailed description about all these patterns. Now we'll get into the code and code all these patterns and see how we can use them in our application. So we are here where we left off in the last video. Now we'll go ahead and add the resiliency into our services. So we'll go ahead and add a folder called resiliency to just depict what we are trying to achieve here. So go ahead and add that folder and we'll name it as resiliency. And then in this we'll start with a class library. So let's go ahead and add a new project, and it will be a class library and we'll name it as circuit breaker. So we'll start with circuit breaker pattern, and in this one we will go ahead and add create with .NET 8. And first of all, what we need to do is to create those 3 enums, and then we'll go ahead and add the model, the state model. So let's add a class again. So we have added the circuit breaker state model, which has state, exception attempt, success attempt, last exception, last state, change date, UTC, and is closed. Now we'll go ahead and add the circuit breaker options. Now this circuit breaker option contains the configuration which the services will be using. It has key, exception, threshold, then it has a success threshold when the circuit breaker half open state is there, and then the duration of the break, and then the mapping of the properties. Now next is the circuit breaker state store, change last state, change date, change state, whatever exception attempt which will be get. Now increasing the exception attempts, all this wire up code is there wherein each services can utilize these methods and set these values. So we'll move on to the next one, which is our helper, circuit breaker helper. The circuit breaker helper helps us in setting up the circuit breaker options, the state store, and also what we have this execute async method, which we can pass the function which we are trying to, or service method which we are trying to do the circuit break or pattern on, and this is the whole state. This is the method which we talked about in the helper on how we are passing the key and setting up the service to utilize the circuit breaker setups. And then we have the different the methods called, which is closed, half open, and when it has to trip, when we call the trip. So that's about the circuit breaker helper. Now we'll see how we can use this circuit breaker setups using the enums, models, state stores, and different varying options which we have configured, and then see how we can utilize that in our service. So we have written the circuit breaker class, which actually implements on whatever we have configured right now. What it basically does, it creates a method execute async, and it passes an HTTP client and the API URL. And then what it does is basically it sets up the properties, the options of the circuit breaker, which we just talked about, exception threshold. Now how many times the success threshold when the circuit breaker half open state is there, and the duration of the break. And then we pass the actual method or the HTTP call, and then we try to get or whatever post we want to do. Now usage of this particular circuit breaker or method, or the circuit breaker dot execute async, we can do is through this one, wherein what we do is we pass the HTTP client which we'll be having in our service and the API endpoint which we are trying to call. Now by doing this, we will be implementing the circuit breaker implementations and using the options therein in the circuit breaker. So that was about the circuit breaker. Now let's move on to the retry mechanism. So I've gone ahead and added a retry mechanism class library and added the retry mechanism options. The options inside this the options we have to configure for the retry mechanism, and we will basically be having only one enum, which is the linear retry policy. Along with that, we will have retry count, time interval, and all these will be mapped to the constructor. We will have a retry mechanism base implementation input, and then it tries to run the retry mechanism or based on the retry count. We have the retry mechanism strategy, which inherits from retry mechanism base, and it adds the time delay to the retry mechanism. And then we have the retry helper, which does the retry, and it takes the retry mechanism strategy with the options and implements the retry logic. And this is how you will use the retry mechanism. You will have the execute async method in which you will be calling the retry helper, and the retry helper will apply the retry based on the HTTP client and the API URL which you have passed through this implementation method. This specific call will go inside your specific services, and you will pass the client and the endpoint which you are trying to call, and the retry logic will work based on the retry count and the interval that you want to set. So that was about retry mechanism. We'll move on to the bulkhead implementation now. Now in the bulkhead we will set up the semaphore slim. Now the semaphore slim is used to control the maximum number of concurrent requests that you will be allowing, and the execute async method acquires a slot and executes the provide function and releases the slot once the execution is completed. So in the constructor we have the semaphore slim, which is, and then we have the wait async on the semaphore. And the way we can use is something like we pass it the bulkhead implementation into our services like this, passing the max number of concurrent requests that you will allow, and then in the get async or post async you will do is you will use the bulkhead to execute that async method on it, and then the response will come around it based on the maximum concurrent request that you have configured. So that was about bulkhead. Let's move on to the timeout. Yeah, so in timeout, this is the timeout implementation where we have the timeout helper with a generic and non-generic implementation. Both of these takes the task which you want to configure to use the timeout, and it takes the timeout duration which you want to set. Then the use case and the use of this specific implementation could be something like this, wherein what you're doing is, let me just comment this off. So what you will do is you will pass some async operation on passed with timeout, and that will pass to your specific method, and you'll pass the amount of seconds which you want it to have the timeout on. Now let's move on to the fallback pattern. Now fallback pattern is something that relies on the retry mechanism and the circuit breaker. So we have already talked about the circuit breaker options, retry policies, and all these things. What basically the fallback pattern does, it takes it is something which takes the retry mechanism, how many times you want to retry, along with the circuit breaker options which you can configure, and sets up the fallback function. So that will come into your exception. So see the layers in which we have. The first is the retry, and any issue which happens in the retry step, one falls back to the circuit breaker step, and then if there is anything happens in the circuit breaker setup, then it goes back to your the fallback function which we have. And the way we can use it is something like let's consider there is a primary HTTP operation, and it is trying to do is to call an API and all those things, and what we can do is we can set this up in the like a fallback HTTP operation. Here I have just set the task delay, but basically what we can do is set up the whole steps which it needs to follow. Now that's what I mentioned. When you call the execute async, you call the helper, which is the fallback helper, and on that basis you will be able to set the execute async primary HTTP operation and the fallback HTTP operation. So that's about the fallback operation or pattern. Let's move on to the cache aside pattern now. So cache aside pattern is simple. It is similar to what you would be knowing in terms of lazy loading. What we do is create an object cache, which is a mem cache, and then what we do basically is to set the cache item policy, expiration time, and all those things. And when we have some service to be implemented, we inject the cache aside or cache helper or something which does this stuff wherein you get and set the cache, and that's how you will be able to use the cache helper or the cache aside implementation, and you set the particular cache data and kind of try to retrieve it from the mem cache. So that was about the cache aside pattern and overall the implementation of different patterns. These patterns can be used together in conjunction with the help of each other, whereas also independently. Now there are certain libraries which can be used, like a Poly, which does these things internally, but this was a full scale implementation on how you can utilize them in your application, and we will be using these implementation in our different services which we talked about initially. So that was pretty much about creating resiliency in your microservices. Hope you like this video. Please press like and subscribe to the channel. Have a nice day.